Hey guys, today we are going to take those polynomials that you've been working with and we are going to add them together, okay? So let's begin. Today we are going to be adding polynomial expressions. Keep in mind this is a polynomial expression. Let me just ask you, what kind of a polynomial is this? That's right, it's a trinomial. What's the degree of that trinomial? That's right, it's 2. How about the leading coefficient? Perfect, it's 5. And how about the constant? That is 12. Okay? All right, so let's go ahead. This is what we're going to do. If we are adding polynomial expressions, it's pretty straightforward. I do the exact same thing every single time, okay? The very first thing I do is I look for what is written in front of this parenthesis, okay? And since there's nothing really written there, it's not a 0, it's actually a 1. There's an invisible 1 because it's really 1 times this, okay? And so that's what I do. I multiply 1 times each of these terms, and I get 5x squared. 1 times this is minus x, and 1 times that is plus 12, okay? And then I look at the next, this happens to be a trinomial as well, and I notice this is plus 1 times that. There's one of these, right? So I'm going to multiply the 1 times everything inside there. So plus 14x squared plus 1 times 2x, so plus 2x, and then plus 1 times negative 12, and that's just negative 12, okay? And that step is pretty important. It doesn't seem like it right now. I think a lot of teachers just say, oh, get rid of the parentheses. And that's true, but that's only because we're adding. Tomorrow or next time we meet when we are subtracting, it's going to be a slightly different story, okay? All right, so here we go. Now all we have to do is combine like terms. Remember what like terms are? Well, here's a 5x squared. Do you see any other x squareds anywhere? Hey, there's one right there. So I could combine these two. This 5x squared, and there are 14x squareds. If you have 5 of them and 14 of them all together, you have 19 of the x squareds, okay? All right, let's look for other like terms. Here's an x to the power of 1. Here's an x to the power of 1. So here I have negative 1 of those x's, and here I have 2 of those x's. Or in other words, say it's like I have 2 x's and then I lost 1 of the x's. Or I have 2 apples and I lost 1 of the apples, right? Minus 1 is I lost it. So if I have 2 of them and I lost 1 of them, well, I have 1 of them now. 2 minus 1 is 1. So now I have this and this together gives me 1 of them. I have 1, so it's plus. Okay, so plus 1x. And finally, we have 12 and a minus 12. And 12 minus 12 is 0. So I could put plus 0 if I really wanted to. You don't need to. Okay? And you also don't need to write this plus 1x. It's just plus x. Okay? So this could be, if you really wanted it to be, 19x squared plus x. Okay, that would be the final answer, or simplification. Okay, by the way, what type of polynomial is that? That's right, it's a binomial. All right, here we go. Same thing here, right? Adding these two polynomials, there's a 1 outside here, so 1 times all of that is all of that. So here we go. 7p to the 4th plus 8p squared plus 3p plus 1 times all of that. So it's 1 times that is still the same thing. So plus 9p to the 4th minus 5p squared minus 10p. All right, let's combine like terms. Okay, well, I have 7 of the p to the 4ths. Do I have any more? Here I have 9 of the p to the 4th. So if I have 7 of them and I also have 9 more of them, how many do I have all together? Well, that's 16 of them. So I have 16 of the p to the 4ths, okay? Then I have 8 of the p squareds, and here I have negative 5 of the p squared. So here I have 8 of them, and here I'm taking away 5 of them. So if I had 8 and I take away 5, that leaves me with exactly 3. 3 of the whats? 3 of the p squareds. So 3 p squareds. And finally, here I have 3 p's, and if I look down here, I have 10 p's, but I'm actually subtracting 10 p's. So I start with 3, I'm subtracting 10, so 3 take away 10 is negative 7. Negative 7 of those p's, okay? All right, let's do one that's a little more challenging. Look at this guy here. That's some madness going on, okay? But all we're doing is the same thing. We are looking out in front. There's a 1 there. I know you don't see it, but it's there. And we're going to multiply that 1 by everything in here, so you get the same thing that you have there. So minus 2a to the 4th b cubed plus 5a squared b minus 3ab. Okay, there's a 1 here, so positive 1 times all of that is still all of that. So plus 8a to the 4th b cubed minus 7a squared b plus 10ab. Now let's combine the like terms. Well, look at this. This is a funky one. Remember, to combine like terms, to make sure they're like terms, the variable has to match and also the exponents, okay? So if you look at this, there's an a and a b, 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 and an a and a b, and an a and a b, right? Tons of a and b's, okay? But the exponents have to match too. So here's an a to the 4th, b to the 3rd. Here's an a to the 4th, b to the 3rd. So we could combine these guys, the negative 2 of those and the positive 8 of those. So if you have negative 2 of them and positive 8, you can also think of it this way, 8 take away 2 of them, right? So you get 6 of those things. You get 6 of the a to the 4th b cubes, okay? And then you have an a squared b. Do we have an a squared b anywhere? Ah, there's an a squared b. Okay, so look, I have 5 of those a squared b's, and here I'm taking away 7 of those. So if I have 5 and I take away 7, can you do that? That's right, it's negative 2. So now I'm left with negative 2 of the a squared b's. Okay, and finally I have an a and a b, and if you look down here I also have an a and a b. So here I am taking away 3 of them, and here I'm adding 10 of them. So if I have 10 of them and I take away 3, that leaves me with 7. So that's a positive 7ab. Okay? All right, last example, and then we're done. Yay! Here it says we are going to write a polynomial that represents the perimeter of the rectangle. Oh my gosh. Geometry. Blech. Well, first of all, good thing we know what polynomial is, right? Polynomials, they're all over the place. They're everywhere. Yay! Perimeter. We have to know what the perimeter is. Anybody? Anybody? All right. The perimeter is the distance around the entire thing. That's perimeter. Okay? All right. So the perimeter means we need to know how long it is from here to here, from here to here, from here to here, and from here to here, all together. Okay? Well, do we know how far it is from here to here? Sure we do. It's 14x minus 8. Do we know how far it is from here to here? Yeah, it's 14x minus 8. Similarly, we know the distance from here to here. That's 9x plus 2. And so then do we know the distance from here to here? Yeah, that's also 9x plus 2. I don't know, feet or centimeters, okay? This is 14x minus 8 centimeters. This is 9x plus 2 centimeters, okay? So it is distance. Even though it looks funny, I think you are probably thinking, oh, it's 14 centimeters and this is 200 centimeters, whatever, okay? All right, so here we go. If we're going to find the perimeter, okay, we want to write a polynomial that represents the perimeter of that rectangle, we have to add all the sides. So we add the distances. So that's going to be 14x minus 8. So I'll write that. 14x minus 8 plus 9x plus 2. So plus 9x plus 2 plus this distance, that's 14x minus 8. So plus 14x minus 8. And then plus this distance. We go around the entire rectangle. So that's 9x plus 2. So plus 9x plus 2. Okay? And now all we have to do is combine like terms and we're done. Yippee. All right, well, here we have 14x's. Okay? Here we have 9x's. Here we have 14 more x's. And here we have 9 more x's. So how many x's do we have altogether? I'll let you figure that out. Did you get 46? I did. Okay, so I have 46 x's altogether. And I'll just double check. 14 plus 9, that's 23. 14 plus 9, that's 23. 23 and 23 is 46. Yay. Okay, then we're going to combine these guys. There's a negative 8, there's a plus 2, there's another negative 8, and there's another plus 2. Can you do that one? Okay, I get negative 12. All right, negative 8 plus 2 is negative 6. Negative 8 plus 2 is negative 6. Negative 6 and negative 6 is negative 12. So there's my polynomial that represents the perimeter of that rectangle. All right, hopefully that was helpful, and I will see you guys soon. Peace.